All right, so we are doing worksheet 36, and it is on 5-1. It's continued from what we did with perpendicular bisectors and angle bisectors. We're talking about the medians and altitudes of triangles. So a median meaning middle, okay? So the same idea, just like the median of a road. The median of a triangle is a segment whose endpoints are at the vertex of the triangle and a midpoint. All right, so that's important. So the median goes from one vertex to the midpoint of the opposite side. So if you take a minute and look at this, here's my vertex C. D is a midpoint. Okay, so that's the median line. D is a midpoint. And so the idea is these segments are congruent to each other. AD is congruent to BD. Because if this is a median line, that means I have a midpoint. Okay. There are 3 medians in every triangle. So if I wanted to draw all of them, and let's take a look at this next picture here. These are all medians. So every triangle has 3 medians. So look, I go from T, the vertex, to the opposite side Z. I'm going to go ahead and trace that. That is a median because this is congruent to this. So focus on that one side. Now let's look at the next one. Vertex is R and it goes to Y. So this is a median because it goes from vertex to midpoint, and these 2 segments are congruent, or sorry, that segment is congruent to here. All right, and then you have one more, and it goes from this guy right here, V, to the midpoint. So that's how I know they're medians. If I can get this to work, there we go. They're median lines because they go from vertex to opposite midpoint. Okay? How do I know these are midpoints? Because I'm either told it's a median line, so I know it's a midpoint and it makes this cut in half, or I'm told this is a midpoint, and when I see that connect from midpoint to opposite vertex, it's a median line. All right, so how do you draw a median line? You locate the vertex, boom, there's V. Determine the opposite side. So the opposite side is not touching. These are adjacent. This is the opposite side. And you find the midpoint and you connect it. And then you mark the segments congruent. So that's how you're going to draw it. All right, so let's go ahead and draw some. Now, this doesn't have to be perfect, okay? If you were constructing it with a compass, that would be different. But we're not constructing it. We're just eyeballing it. So how do I show the median? Find your vertex to opposite sides midpoint. All right, so when you go to look at this, here's my vertex, boom, got it. And then I'm going to sketch a midpoint about here, and I'm going to show it's a midpoint by marking these congruent. And that's all I have to do, and then go ahead and connect that the best you can. Okay, so let's find the other medians. 36. There's my vertex. I'm sketching in a midpoint. Remember, this is not exact. We're just estimating. I'm showing it's a midpoint by marking them congruent. And then I'm going to connect my vertex to my opposite midpoint. There you go. I know I have another color somewhere around here. Okay, and the last one, find your vertex, mark your midpoint. So again, this is not an official midpoint. Even measuring it doesn't give you the best midpoint. You actually would construct it with a compass, that little thing that has the angle on it, and you spin it around. And then just connect these. Now, do you notice, if you did it fairly well, that these all come together at one point? All right, so let's go ahead and do this again. Now, this one is a right triangle. Do you notice that? This one was an acute triangle. This one's a right triangle. So find your vertex. Any one of them's fine. Estimate your midpoint. Prove to me it's a midpoint by telling me it's congruent. So it's really important to have these marks. And then go ahead and connect that. And I hope you can do better than I just did. All right. Find your next vertex. And guys, again, I can't stress enough, these sides are adjacent. This is the opposite side. So mark your opposite midpoint. Show me it's a midpoint by marking these, and then go ahead and connect. All right, we got one more vertex to connect. So these are all our median lines. So find your vertex. All right, so we are finishing up this third line here, and we are going from vertex to the opposite midpoint. So how do you show me it's a midpoint? You mark it. If you mark this congruent to this, you are telling me this is supposed to be midpoint. Median lines go from opposite vertex to opposite midpoint. And do you see that point in the middle? They all meet at one point. Okay, so go ahead, take a minute and draw me the three medians. But when you draw the three medians, you have to mark the triangles accordingly. All right, so let's do this last one. I got a different color to maybe help. I'm picking this vertex first, and then just estimate what the opposite side's midpoint would be. And go ahead and mark these two congruent to each other, and then connect. So that is a median line from vertex to opposite midpoint. So that's how I know it's a midpoint, because it's marked congruent. So that's what you need each time you create a median line. So find your vertex that you want, and then these two sides are adjacent. This side is opposite. So show that that is a midpoint, okay? And then sketch the line in. And connecting vertex to opposite midpoint. All right, we have one more here. Here is my vertex. Here is my opposite midpoint. And I'm going to show that with these three tick marks. And then let's go ahead and connect. Now, I know these notes don't talk about it, but I want to talk about that middle point again. So we have this point in the middle where all three meet. That point is called the centroid. So each one of these has a centroid. If you have done your median lines right, all three medians, they will meet at one point called the centroid. Now, you can see that this one's a little bit off, but it's pretty close. So it is the meeting point of all three median lines. It's actually a balancing point. So if you physically had a triangle cut out of maybe a piece of wood, and it was, the same thickness, and you drew the medians, you should be able to balance it on that centroid. Okay, that's the purpose of that. All right, now we're going to change, and we're going to go to altitudes. Okay, altitudes have to do with height. So I'm going to write that right here. Altitudes are our height. So if you're in a plane, they're going to tell you that you're flying at an altitude of however many thousand feet you are in the air. But altitude is important because it always is 90 degrees. Otherwise, we can have different heights. So if I drew a triangle like this, and I said, I need to put this triangle in a box, okay? I want this to sit flat, and I want the top. So picture me needing a box. I want that to sit flat on the bottom, and I need enough room for this peak to be there, right? That's the height, guys. I don't care how long this side is. I'm not trying to stand the triangle up on its tip. I'm going here. And so the height I need comes from that vertex to the opposite side with the 90-degree angle. Now notice that doesn't have to be in the middle. This piece is longer than this piece. But the altitude always goes from vertex to the opposite side, and it forms a 90-degree angle. And sometimes the altitude can be a little tricky in triangles, and we're going to see that. So altitude of a triangle is a perpendicular segment, meaning 90-degree angle with side. Okay? It goes from a vertex to the line containing the opposite side and perpendicular to the opposite side. So basically, it's going to be vertex to make a 90-degree angle with the opposite side. So let's take a look. Every triangle has three altitudes also. Altitudes can be in any of three positions, so we'll talk about that. Now, if you have an acute triangle, we're pretty set. Here is an altitude, so let me highlight this. I'm going from S over here to this side. Okay, so I actually can't, and when we did medians, we put a point and we connected it. You can't do that. What you would be doing is taking something and saying, okay, if I connect this point to my red line here, that doesn't look like a 90-degree angle. Okay, here is a 90-degree angle. That is what you're going for. See, if I extend it, my yellow paper does not make that 90-degree angle. So that's what you have to look for. So you would be adjusting it. And so we create this line that goes across and it makes a 90-degree angle. And they just show that outside of it. All right, so let me trace another one for you. Again, it's almost hard to come in and know where to hit it. So you would take something and you would look for that. So if I come here, it's not 90 degrees. If I straighten it out, do you see my corner? See that 90 degrees? And so that's how we create this line cutting through, and it's 90 degrees. Okay, we have one more to look at. Here's my vertex. And you can see again, if I put this in here, this vertex to the opposite side makes 90 degrees. If I go this way, see how it's not 90 looking anymore? My paper doesn't line up. So this one's a little trickier to do. Okay, there's my 90 degrees. So these altitudes, they can be inside the triangle. Okay, so look, this goes from opposite side, not with a 90 degree, and it connects here. That's what makes that an altitude. Now, if this is an isosceles triangle, that's going to make this broken up equally. This is the hard one, guys. If I have an obtuse angle, okay, so look, if I do this angle to here, that's an altitude, and I'm fine with that. That's good for me. And then if I go to do this one, if I try to connect this to the actual triangle side, do you see that I definitely don't get that 90-degree angle until I come in here? So sometimes you have to extend this line so you can get this 90-degree angle. This is one of the hardest ones to see. You have to extend one side. Same thing here. If I wanted to do this guy, look at this. No matter what I do, I can't get this, guys. Look, I'm trying to connect here. That's not a 90-degree angle. If I go that way, it's not even close. But if I swing it this way, do you see it? It's not easy to see, but I would have to extend this line, and then I can connect. So my altitude might be outside of my triangle. I think this is one of the hardest ones to see. So can you picture this side being extended here? Okay, and then I drop. So the height from this vertex to this side is right here. This is one of the hardest ones to see. All right, a right triangle, boom. Go from here to the opposite side, it's the side. That's one altitude. Your other altitude is also right here. So two altitudes make 90, and then you have one more altitude, guys. And it's probably gonna look about like that. So altitudes basically take vertex to opposite side 90-degree angle. They have nothing to do with being a midpoint. Okay, with that in mind, we are going to draw altitudes here. So locate the vertex. From the vertex, try to make a 90-degree angle. So number 4 is like what we just did. Here is a right angle. So here's one altitude. I'm just going to sort of trace the outside of it so we can see we did it. Here's the other altitude. I'm just tracing on the outside. And then the one that's more common goes from this vertex and try to line it up so it looks like it hits a 90-degree angle. That's all we know is it's 90 degrees. Okay, that is a right triangle. An acute triangle is a little easier because we see them all. So this one's going to come straight down. This actually looks like an isosceles triangle. So I'm just doing a dashed line because it's truly, you can make a solid line, but you have to show it with the right angle. So there's one. Here's my vertex, and I think it's going to line up about here. So again, we're just estimating, but do you see how that looks like a 90 degree? See how I can put my corner of my paper in there pretty well? All right, and then we have one more. Vertex to opposite side, and we get that 90 degrees. Notice that these are connecting in one point. Did you guys notice these connect in one point? These connect right here. These connect right here. And then this is going to be the harder one. So we'll start out with the easy. The easy one is here to the opposite side. So that's easy coming off of the obtuse angle. But in the obtuse triangle, it's harder to do these other ones. Guys, if I try to connect from here, from here, let me get another color. If I try to connect from here to here, do you see how it's not going to be a 90-degree angle anywhere here? But if I extend this line, go ahead, extend this line, and then create something that should be close to 90 degrees. So you have to think about extending your line. I think I needed to bring mine out a little bit. All right, then I have one more. Go from this vertex. Guys, my goal is to go from this vertex to this side. If I extend the line this way, it's even less of a 90-degree angle. I want to extend the line going this way, and then I can see that right angle. So this would give me the altitude. How far is it from this point to this point if I was putting this in a box? Do you see that box I did? All right, then all three of these meet here. All right, when you look at all of these, and it's not as easy to see on these, but this one's the best to see. Where all three altitudes meet is called the Ortho Center. So where all three altitudes meet, sometimes it is on the triangle, is the Ortho Center. And on this one, it is on the vertex where the 90-degree angle is. That is your Ortho Center. Okay. So on the back, we're going to take a pause here. You're going to either decide if we have median lines. When there are median lines, we're looking for tick marks because we're looking for the midpoint. And when they are altitudes, you're looking for the perpendicular or the 90-degree angle. So on this one, they ask me what FD is. So I'm looking at FD, and it goes from this point over here. And do you notice that these are marked? So that means that FD is a median line. All right, AC. Well, AC, is it a median? Is it altitude or neither? AC is neither. Nothing's marked congruent. It doesn't go from a vertex to the opposite side. So AC is neither. And BG, right here, it goes from vertex, it comes down. It looks like it could be a median, but these aren't marked. What I see is a 90-degree angle. So that would be considered an altitude. All right, so take a second and work on the other sets here. And then you can unpause this. All right, LQ goes from here. And if you look, this is a midpoint because we see these are marked. So that makes LQ a median line. RM, all right, now RM is a tough one because you're looking at this 90 degree, but that's the vertex. Ignore the 90 degrees. It cuts over here, and you can see that this is marked congruent. Okay, so that is also a median line. And then LR, gotta find it. LR comes over here, and some of we want to say it's nothing. If you take a minute and you look at LR, it comes through here, and it meets at a 90-degree angle. So this would be considered an altitude. All right, so next triangle, a little bit tricky. So let's find UV. So UY, couldn't find UV. Your triangle is out here. It's a little bit hard to see. This is your triangle because there's a lot of segments going on. So that's your triangle. So U to Y, there's a 90-degree mark there, okay? And so that is perpendicular, and so that creates an altitude. And some of you might be looking at that thinking, oh, wait a minute, these tick marks are here. That's for the point W. So this segment and this segment are current. This is 90 degrees. Now, Z to T, okay, goes from this vertex. Now, this is an obtuse triangle, and this comes down, and they had to extend this line. That makes this an altitude. And then U to W, we just talked about that a minute ago. That is a midpoint. These segments are congruent, and so we end up with a median line. Okay, last one. Again, find that triangle. It might be a little hard to see, so I'm looking at the vertices here. So here is the triangle that we're focused on. There's a lot of lines going on. Maybe the triangle should be a little darker. So there's your triangle. A to D. Okay, well, here's A to D. It's definitely not marked 90 degrees. It's not marked congruent, so this one is neither. All right, now looking at F to B. F is here and it goes to B. It's definitely not a 90-degree angle. It's not marked, but I see that this is marked, that these two are congruent, so that makes that a median line. And then A to E. Okay, we'll find it. Here's A, and it goes over here to E. Do you see that we create that 90-degree angle? So AE is an altitude. It's the height of that. Okay, so make sure you have the difference. A note card would be really helpful.